So when you talk about software testing, you must be knowing now in the software life cycle, when do you do software testing? Can somebody tell me the phases of software life cycle? Yes. What are the phases in the software life cycle? Where do you start? Be quick, otherwise we are wasting time. You are not going to talk, only going to chat. Okay, even in the chat. Rather than planning, what do we say the first phase is? Now your exam is close by, you need to know these terms. What is the first phase in the software life cycle? Somebody, if you are not, who don't want to unmute and talk, can you please type in the chat quickly? Because we are just, we are already late. What is the first phase in software development life cycle? Not exactly. Yes, we need to have a concept. Now say if you are a software developer, what is the first task that you would do? There is a special term for that. And in your book, in the software, in I think the book 2, the first one must be only C programming. That is the first activity that you did. And maybe the assignment also, most part of the assignment was on this. What is it? Can somebody type the all phases, all the stages? Analysis, design, development, testing, install, and maintenance. Okay. So to analyze, you have to find the requirements, right? So requirement analysis or requirement elicitation and analysis is the first stage. After an elicitation means gathering, that you are going to analyze the requirements. And as you see, testing comes later. After analyzing, you have to do a design, and after the design, programmer will do the programming part, and during the programming part, and after the programming part, making sure that what you wrote as the program is correct, that you do the testing. So this is where we are, right? So these things you have to remember. If somebody asks you, what are the phases of the software life cycle? Now you must be very familiar. Don't start with analysis, say requirement gathering, and you can say requirement gathering and analysis. Then the second one design, third one development, fourth one testing, and the fifth one installing and maintenance. Okay. Or you can even say installing or deployment, and maintenance as the last one. Right. So can somebody type it the way I said it? Can somebody type so others can see the software development life cycle? Nobody is typing. I'm not going further. Asela, who wrote this, at least can you type? Asela? Thank you, Asela. S- When when we talk about testing, so why requirement gathering and analysis is very important is testing is done mainly to check whether the program you wrote is correct and the program output you get is matching with the requirements that you gathered earlier. So always testing has a direct connection to requirement gathering. These are the content in this slide set, but there are two more slide sets. So under software testing, you should know what is the difference between verification and validation that we will discuss. And under software testing, what is system testing, component testing, and how to design a test case. Test automation is there. We would not be doing anything on test automation. We will see why test automation is necessary. And then testing strategies. There are two main testing strategies that we discuss: black box testing and white box testing. Where we do black box testing and where we do white box testing, and how to write test cases for these two test strategies are the things that you would need to know, because you may get a question in an exam asking about what is to differentiate between black box testing and white box testing, and given a scenario and write a test case for black box testing and white box testing. Computing test coverage we will not do, so that we are not going to do. So in the test software development process, these activities are needed. The specification, defining what the system should do. After gathering the requirements and after analyzing the requirements that you found, you have to, as a software developer, write the requirement specification. That is the official document that comes as the output of the software requirement and analysis stage. So based on that requirement specification, the software architect will be making the design. And based on the design, the implementation will be done by the software engineers. So please remember, these are different stages, and in the software industry, say if it is a fairly big project or a complicated project, a bigger company, there will be different people doing these things. For example, requirement analysis and requirement gathering and analysis will be done by business analyst, and the design usually is done by a software architect, and the implementation part will be done by software engineers and associate software engineers, etc. And during the development, software engineers will also be testing their code whether it's correct or not. Then it would be given to the quality assurance engineers or testers. And we normally, when it comes to software testing, we have this word quality assurance also going in line with testing. So quality assurance means, so before the fault comes, making sure that the fault doesn't arise, and yeah, making sure that precautions are being done for not for that fault to arise. When it comes validation, so validation is coming after all this testing, uh, after implementation, or after you install the software before you install the software for the customer, for checking that the software system that you developed is really what the customer wants, or um, what you built is what was actually expected. So as you see, this validation is directly related to requirements. So now do you understand why I started asking about requirement gathering and analysis? There is a direct relationship with testing and requirement analysis. The last part, or the maintenance or the evolution, means when you deploy or install a software system to a customer, it will not be just lying there as it is. There will be certain changes necessary because the hardware may change. There would be new fast computers, or what you developed for the desktop may need to be given via the network, or what you developed as a web application now will have to be given as a mobile app. So the evolution is the changing of the system with response to changing customer needs will be happening all the time. So usually if a software system is made with the developer, the development company would be having a maintenance agreement with the customer, the customer who buys the software for the maintenance part, so that they will attend to this task in the evolution. When we come to discuss programming, and you must have heard the term debugging. You did this C language part. You must have done the labs and the mini project. So to make sure that your program is working properly, you would have done this activity called debugging, isn't it? That's finding the errors in the program. So in the programming, the task is that you are translating the design into a program. That is called the design. Translating design into a program is called programming, and removing errors or faults from that is called debugging. And it is said that programming is a personal activity, so there is no general programming process, and programmers carry out some testing. That is to make sure that whatever you wrote is correct. And if we look at the debugging process, in the debugging process, you have to go through the following stages. You have to first locate the error, and then design how to repair the error, and then repair the error, and then retest. So first you have to find it, then have to think how to do the corrections, and then do the correction, then retest, test it again. So this is the debugging process. So when you are doing, you must have done this while you were doing your lab 3 and the mini project. When we come to software verification and validation, as I said earlier, verification and validation is intended to show that the system conforms to its specification. That specification is the official document that was made at the after requirement analysis stage, and it meets the requirement of the system, requirements of the uh, system as requested by the customer. There is a definition for verification and there is a definition for validation. When it comes to verification, the definition says the process of evaluating work products of a development phase to determine whether they meet the specified requirements for that phase. So verification ensures that the right product is designed and deliver all functionality to the customer. In a simple or simplified way, since this is a bit complicated, by verification, you are trying to answer the question, are we building the product right? Whether you are building the product the correct way. So the items for evaluation will be the plans, the requirement specification, design specification, test codes and test cases, etc. And what is the meaning of reviews and meetings? Reviews and meetings are to evaluate the requirement and the specification with the code. So that is, somebody can, before even you run the program in a computer, there is a process called desk review where some other people would be reading through the code. So then by reading them, they can identify whether there are any errors or mistakes, etc. So that is the meaning of reviews. So verification is whether the code or the program is being developed correctly. So it is for this, it is for the purpose of verification that we use these testing strategies. And when it comes to validation, the validation is done at the end of the development process. Now here, verification, it says process of evaluating work or the products, not the final product. So this is before the final product. This is like end of the each phase. You have to check whether your programs are correct. Now validation is done at the end of the final product. And the expectation of the validation is that are we building the right product? Or that means whether we build what the customer asked us to build. So this is directly related to the requirement that you gathered. So the final product we test to show the customer that what was being built is actually what was asked. So here there is actual testing with test cases, means there are test cases. When we come to test strategies, you will see the strategy called black box testing, where we give input and see whether we get the output that we expected. So giving the input and finding whether it gives a correct output. But when in the verification, reviews and meetings, other than the software developer finding his or her own mistakes, it is all about the code that has been written, not the final product with the inputs. This is of different phases. The difference between verification and validation. So please remember there is this differentiation. Here we are in the verification, we are trying to answer the question, are we building the product right or the product correctly? And in the validation, we are trying to answer the question, are we building the right product? So if you look at this diagram, see how the testing relates to phases in the software lifecycle. When you, with the requirement specification, you have to map the test called acceptance test. That is the last testing that is being done. So validation will come here with the acceptance testing, where the customer accept the product. After requirement specification, we go for design, the high level design or the structural design, and then the detailed design, and finally the code. So as we discussed, during coding or programming, the developers or the software engineers or programmers, whatever you call, the person who write the code will be testing his or her own small programs. He or she will be testing. With this small units will be tested with the detailed design that we call unit testing, and maybe many units will be integrated to a full system, and it could be coming from several programmers. Several programmers will be doing small parts of the project, and it will be integrated together. And then after integrating, it is tested with the design. So the mapping of testing and the software lifecycle, it matches this letter V. So as you see, the final testing is matching, has to be mapped with requirement specification. So please remember this diagram also. Yeah, what is most important here is how the final testing map with the first phase of the software life cycle. Then when we discuss different testing strategies, unit testing is what? Unit testing means individual components after programming, they are being tested. And module testing is a collection of units or collection of dependent components are tested. Then the subsystem testing. Then several modules are integrated into a subsystem and being tested. The focus here should be on interface testing. That is mainly with the user interface. Then the system testing. Testing of the system as a whole. So if there are sometimes the software team may be like 2 or 3 people. So when if you're in computer engineering, when you do your group project, not even in computer engineering, yes, engineering level 4 group project, you will have 5 people in the group. So five of you would be doing small parts of the same project, and ultimately they will be integrated into one. So that is where the system testing is done, after getting all these small pieces together. But when it comes to a complicated project, there could be even 100 people in a project team who are doing different parts of the same huge program. So system testing is the task of testing the system as a whole. And finally, acceptance testing. This is done with the customer data to check that what you built is acceptable to the customer. Testing with customer data, the final testing. This diagram is also the same as we described. We do unit testing, modules testing, system testing, and acceptance testing. And if there is anything to be changed, we will have to go back. If any change, we will have to go back doing system testing, integration testing, component testing, and test that small unit again and see whether it fits. So after you deploy the software system to a customer and they ask a small change, for example, say the tax calculation is given by the government, given now say you have only one tax tier, like there is only one tax tier or two tax tiers where the people who earn maybe 5 lakh, less than 5 lakhs have to pay this much of tax, more than 5 lakhs this much. So there were only two, but then your customer says the government changed the rule. Now there are 5 stratas where tax is calculated. So you have to give us 5 different if conditions. Then there would be some module where this if condition come, where this algorithm you have to change if this is less than, like that, for 5 cases. When that change being done, you have to then again start with the unit testing. You have to do unit testing, module testing, subsystem testing, and then integrate it to the full system and try with again user data. So that is why the maintenance in the maintenance agreement usually is quite high amount, and most of the time people wonder, to do such a simple change, why do software developers charge so much? It is mainly because, you see, even if you do a minor change, the whole testing process has to be carried out, and it takes maybe a lot of testing time and lot of people effort. Right. Then when we discuss testing methods, there are two major testing methods that we discuss. One is black box testing, the other one is white box testing. So what do we mean by black box testing? Can somebody answer? From what you have heard or known, can somebody explain what is, not explain, at least say what is called black box testing? When we say black box testing, there are set of techniques in there, but they have a common feature, like why they are categorized black box testing. Can anybody answer? Why do you think this method is called black box testing? Yes. Can somebody? Oh, there. I'm not going to say what is in the screen. Even you can see the screen, or what does it come to your mind when you hear the word black box? Why do we call it black box? Yes. Can somebody unmute and say or write on the chat? What would be the simple reason that we call this testing method black box testing? Yes. Yes. Not that tester is unbiased. We can't really see what is inside. So in black box, when something is called a black box, it means we can't see what is inside. And we are, so uh, here the tester, when he tests the program, he doesn't know whether there are loops or what is the algorithm, whether there are if then else conditions. The tester does not know. Tester don't look at the code. He only looks at what is the input and what is the output. So what happens in between the input and output is not known for the tester. That is why this testing method is called black box testing. So most of the time for user acceptance testing, this is the method that is being carried out, because we get the user's input and then we have to show the user, all right, for your input, this is the output. And the user doesn't have to know anything about the algorithm that is being running inside. And for validation, this testing is this types of testing is used. Under black box testing, there are it is not just one, it is a generic name, a classification. There are we will also look discuss two methods. There are more methods under black box testing. One is boundary value analysis. For example, say it is given that x is between minus 1.0 and plus 1.0. So if the input is given like that, you have to check the boundaries, whether the system only accept x like this. For boundary value analysis, what you usually do is you get the minimum, say minimum is minus 1.0 and minimum minus 1. You have to get the minus 1.0 and can you see minus 1.001. So that is a little less than the minimum. So these are the test cases. For example, if it is given, what are the test cases to find out whether the x is actually between 1.0 and minus 1.0, then you take the minimum first, the minimum number itself, and something less than the minimum, the maximum number, and plus 1 or a little more than the maximum value. So if you check with these four test cases, most of the time, most of 100, almost 100%, you are sure that your value is in the correct range. This is usually done, for example, think about age, a person's age is needed for application form. And the age, you can see it should be between maybe 0 and 120 or something, because age cannot be minus. And age you can't put 200 or something. So that is why you have to define it less than 120. Uh, Once you define the range, then the boundary values should be the minimum and 1 minus the minimum, maximum, and maybe 1 plus maximum. So in such a case where there are decimals, instead of -2, it is better to have a smaller value like this, 0.1.001, right? So this is boundary value analysis, and it comes under a strategy under black box testing. There is another technique called equivalent partitioning. So here equivalent partitioning we are doing, say there are two variables. There are two key inputs x and y. Now x is between 0 and 1000. So and y is between 0 and 6. Now if we are going to check them separately, there will be uh, many test cases to be done. So if you are supposed to check both together, then it makes sense, or it is more economical if you do the test together, like partitioning the space into both ranges where x falls and where y falls. Then you have to check with only uh, 9 values instead of 4 separately. If you did it with the boundary value this way, for each boundary value you need 4, and for other one also another 4. But then whether these two are matching, there would be more. So that is why it's not only the boundary values, you have to make sure that the integer you select falls between both ranges. So that is where equivalent partitioning becomes useful. When if you are asked to, most of the time you will be given a scenario and will be asked to um, select test cases according to equivalent partitioning or boundary value analysis. Then if you know the technique, the number would be different, and you would be able to say these are the test cases that you can use. So please remember, when we talk about testing, there is a method called absolute testing, that you test each and every step and each and every uh, decision or the iteration, etc. But that is not practical. So as a tester, testers are supposed to find the optimal or the optimum number of test cases. So that is why these techniques are useful, so that you are not going to test each and every step. Instead, you will find test cases that will um, cover the possible range. Then when we come to white box testing, so as the name suggests, it is also closed glass testing. Here, the tester can see what is inside the program. So the whole algorithm the tester is looking at. Let's look at the example like this. Now, in white box testing, you would be given an algorithm like this, and then you will have to find the test cases that would cover all these conditional statements, all the branches, and you need to figure out what is the minimum number of test cases that would do your job without going through, say, you can go without going through without having lot of test cases. What is the minimum number of test cases that you can use so that to make sure all these branches work? For example, if you choose your values like this, it can be even done with two test cases. For example, try putting a equals 2, b equals 0, and x equals 0, 4. What is the line that your program would go? You can substitute and see. If a equals 2 and b equals 0 and x equals 4, uh, can you tell which path this will traverse? Yeah, you can type on the chat. Can you substitute and see? Substitute these values, yes. Yes, so can you go through all these links? This one and all this. If you say A, B, D or A, C, B, how can you write now? If you substitute these two test values, what will happen? What is the path? Can you type like what I'm asking is, can you type, I'm just type A, B, C, D, like what is the path? No, not A, B, C, D. What is the path? With the first test case, can somebody type it so the others will also understand? A, C, D. Okay, A, C, D. If you do the other one, A, C, B, E. Wait. A, C, D happens when if A equals 2, B equals 0. Yes, you come here, true, and you go here, and X is 4. So AC, FX is AC, okay. BE, right, the second one is correct. ACBE, right? So can you substitute the other one? A equals 1, B equals 1, and X equals 1. What is the path? Can somebody substitute and tell me? The second test case, A equals 1, B equals 1, and X equals 1. If you substitute here, what is the path that you can traverse? Some say ABD, some say ABE. Okay, most of you say ABD, right? I suppose it. Okay. So if the question is, how do you cover the full algorithm? Then you can do with these two cases. And if it is said, how do you check the if the nails part, the conditional test case, then you will have to say for first condition a set of values that becomes true, and for the second and that becomes false, and for the second condition also, for which values that you would be getting true and for which values you would be getting false. So there could be 4. If it is asked that how do you test the conditions, then there would be 4 values. But if it is said that what are the optimal values that you can check the full, the whole of the algorithm, then you can do it even with 2 test cases. And there is, so the last one, another valid set of test cases, can you see? It covers the same path. So then it is useless, right? So what you need to understand is when you are testing, uh, you need to figure out um, that both black box testing and white box testing are necessary, right? So this is about all under testing. Let me give you a small exercise. Uh, that is okay. Can you go to this activity? If you go to this link, you will see an activity. Go to that activity and see how long will it take for you to finish the activity and type in the chat. There are about five or six different test strategies to find. Go to the activity and start. It is a little game. And then type how long it will give you uh, the time that you took to do that. See whether you can do that. I can show. Let me see. Did you go to this site? So here you can click begin and see whether you can find this. All right. So these are the new words that you learned. Most of the new words that you learned today are here. Verification, black box, white box, path testing. We didn't talk about re-engineering, but we did talk about validation, boundary, bug. Yes, and if there are bugs, you have to fix. And gray box. Gray box is like having a mix of black box and white box testing. Yes. So I'll stop sharing, do this, and I will get the other slide set. From here, I will briefly touch upon software deployment. So after testing, you said there will be implementation or installing it in the customer's premises, and that is called software deployment. So software deployment, there are few now. In very early days, after programming, it is like straightforward that you deploy it as a uh, you have it as a desktop, only maybe in a desktop or network. But now when it comes to deployment, it is a bit complicated because the product you make would be a web application or could be a mobile application. So, and distributed networking system. So software release is not the only activity involved in software development. So these other activities are also there. When it comes, the first one is install and activate. Then software is distributed to users. It could be sent by CD with the lock, or now it could be emailed with the password. And activation, so you are distributing first, and then to activate, uh, you may need the license activating system or password. So after activation only that the customer can use the system. So under deployments like install and activate, deactivation is also must be there. So if you don't want it, like you install and uninstall, deactivate should be there. It is the opposite of activation. And then the other uh, activities are adapt, update, built-in, version tracking. So these are the activities that are coming under software development. Adapt is, it modifies the software system that has been previously installed. For example, a new version is given, and when the new version comes, you are not installing the full system, only that version will give some new features. So it is, so that one. And update uh, is having maybe more new features. There would be features in the new release. And the built-in mechanism of installing updates are built into the software system, and automation of this update process could be fully automatic. Now, most of the time, when you download the executable file, uh, the how to the installing part will be done automatically. And then the version tracking. Uh, when there are several versions, there are version controlling systems that keep track of which version is being uh, used and which version is being done. And finally, uninstall and retire. So like when you install, you should be able to uninstall when it is not no longer required, and software doesn't stay forever. So after few years, definitely the software system is marked as obsolete or is out of date, and it is taken out. That is the end of the life cycle of a software product. So when we talk about software deployment activities, those are the 8 activities that come under software deployment. So under uh, releasing, sometimes software is released so that the testing is done by the customers before the official release. So that is why these um, releases are called alpha, beta, etc., where it is released to a set of customers to check and give the um, corrections. And only after this alpha and beta testing, and most of the time, if it is a new software, these versions are given free, so that some customers, some people would be testing it and using it free, but they will give back they will so the company or the developer can make sure that the software is working properly, and only after that it will be released to the general public, or the uh, or, or handed over fully to the even to the customer. So these are like the stages in software deployment. I will not go into details of this. So there is you must have seen in software life cycle models. There's the waterfall model, spiral model, and like that there is the agile methodology where we use for software development. And in agile methodology, the deployment is different because you have to deploy part by part, not after the full product is done. In the agile methodology, you release a small part of the full product in a small time duration, and then you go in an iteration cycle. It's like a cycle. You go back, do another set of features and release it to the customer. You have to get the full product, you have to go through few of these cycles. And then the toolboxes for deployment, these are in the actually they are written in a I think it's the last or the one before the last session in your book, the toolboxes. It could be a batch file with .bat or CMD file extension that does this installation. When you type the file name at the command prompt, it will appear and get it installed. Or it could be there are scripting languages that you can write these files, and there are packaging tools how to package them and send to the customer. So for when it comes to deployment, these are the tools that will be used: the batch files, scripting languages, packaging tools, etc. So you don't have to remember all these. Only you can, what you should remember is that there are these 8 activities under deployment. So I will not go into details of these, but the slide set will be available. I will stop now and will hand over to Mr. Neil to maybe you can start with software security and then go to the, because the object, if there's no time, you can even skip, right? Isn't it, Neil?
Okay, thank you, Professor Udita. You can hear me, no?
Yes. I will leave. Yes, you can continue. Okay.
Software security. Software security, all software users, say manager, worker, etc., need to secure their software and data from unauthorized users or programs in order to avoid malicious activities. Here, remember, you need to secure both software and data, their data, from unauthorized users. Unauthorized users are person who try to access software or data illegally. They don't have permission to use this software. Malicious activities mean activities to damage or corrupt purposely to the software or data. They are mostly hackers. Hackers mean those persons try to access illegally and try to damage to the software or its data. Virus is another program that will damage to the software and data. Most usually hackers create programs to do damages to the software. Intruder. Usually unauthorized persons are called intruders. Most of the time, intruder try to access a software system through a weak point. If the software has weak points, they can access easily to the software or data. That's why we need to secure the software. Weakness of a security system is called vulnerability. Threat to software. I said earlier, weak points. Mostly those weak points are interception, interruption. Because of these weak points, intruder can interception, interruption, modify, fabrication to the software. We will see what are the interception, interruption, modification and fabrication. You can see this picture. In A, it is not a weaker software, only legal user use the software. It is not accessed by any hacker. The B is interception. Now you can we will consider these symbols to explain this diagram. This symbol is normal user. This symbol indicate intruder. This symbol indicate correct software. This symbol indicate modified software. That means software plus virus code. This symbol indicate it is fabricated software, correct software, unauthorized codes for hidden purposes. Here interception is correct software accessed by hacker. Both the correct user, illegal user and hackers, that means illegal user, can access the software through weak points in software or data. C is interruption. In C, a hacker blocks the software, so the real user cannot use the software. Before this, to do this, B should be available. That is, the hacker can access the software. Later, hacker can do these processes C, D and E. In D, modification. Hacker not only access the software but also modify the software. That means using a virus code. That a real user cannot use correctly and actually cannot use software what he expected way. Fabrication. In fabrication, hacker access the code and user can access the software only through the hacker. So real illegal user use actually this fabricated software. In fabricated software, you actually user doesn't know the software is used by hacker. This software can use correctly, but there are hidden software for the purpose of hacker. This is further explanation to the interception, interruption, fabrication and modification. This is accessing software by unauthorized persons. Interruption is unavailability or blocking the access of software to authorized persons or programs. Example program here there is an example for interruption. A program may be changed to freeze the system at a point when a certain condition is met. For example, the system may stop when the date becomes January 1. When a certain day, that in this example January 1, when the January 1 at a certain time come, the software cannot accessed by the correct user, that is blocked. Fabrication is intruder inserts false transaction to the software with deleting programs, example deleting programs or data, or malfunction of file manager of an operating system. Modification, the software and modifies the software and send to the authorized, example accessing by tapping a communication network and obtaining data or software copies, example bank worker can write the bank software to truncate fractional interest of all the accounts and save the other part. This means the bank worker can access the total amount or deposited amount of other users, bank users. Then suppose the interest, if the interest has 4 decimals, that means we say 19.4447, the last digits he reduced the last digits from this bank account, and very small amount will save in the bank workers account. When this is what happened, this actually happened once, then the bank workers account will increase little by little automatically. Goals of security. confidentiality, integrity, availability. If these confidentiality, integrity and availability are satisfied, the software will become secure. Confidentiality is software should be accessed only by authorized persons. Integrity is can be modified only by authorized persons. Availability is should be accessed at appropriate time. That means even the authorized persons they have a limited access period. Suppose worker can access within his or her working time, and if the worker resigned or retired, then he should have not accessed this software. The company or owner should stop these passwords and user data from this worker. Control to protect software from threats. Control should be implemented for data and software stored in computers. Software should be protected when transmitting data or programs code, when transmitting and setting up correct control internal programs. That means software should be protected when transmitting data or within the in the computer. That means if the software is stored in the computer, that also should be protected, and when transmitting also. When in transmitting, the data or software should be protected. That is called encryption. The encryption is transform actual code to the another format and send it to the destination or the other part. Decryption means at the destination, encrypted code should be converted back to the original code. Here, this plain text or HTML code or software, image, or actually these all are transmitted as binary signals. Binary signals are ones and zeros. In computer also, all the software and data are stored as ones and zeros. That is electrically you can store like that. One is 5 volt, 0 is 0 volt. Like that, there are different formats, and here P is plain text. That text, if you want to send to other destination, first we encrypt. It is indicated by E. And C is a function of P. It is converted some format. P is converted to the some format, so it is C. C sent to the other end, and it is decrypted. Decrypted is also another mathematical calculation. This all are done by mathematical calculation, encryption and or both encryption and decryption are done by mathematical way. D is the decryption. Original code can be obtained by cipher code, a function of C converted by the decryption function. So original plain text can be obtained. Encryption algorithms. Mathematical rules are used to create cipher text. Cipher text is this one, C, from the plain text through the encryption and convert back to the plain text through decryption. Decryption is this one. The keys are used for encryption algorithms denoted by K. Commonly used encryption algorithms are symmetric and asymmetric algorithms. Symmetric encryption is plain text. A key is both one key is used for encryption and decryption. Plain text encrypt by using this key K, and cipher text is obtained by K P. It is a function. Encryption using the encryption function. Then decrypt D, function D using K and the key K and the cipher text. Original, we can get the original plain text P. This is an example, the very simple example. P here, P is plain text, the original message or text, software or whatever, and the K is key. Here K is in this encryption method K becomes 3. This is the cipher text. Cipher text is encrypted message. Here the original message is COMPUTER. Then what happens is cipher text is P2, this P is the original text, we add 3, that means 3 letters, 3 English letters in the alphabet. We add 3 alphabet English letters to this plain text. For this one, C D E F, we include to the cipher F, O P Q R. Shift these these English letters to by 3. This K is 3, key is 3, and in decryption we use again 3. We reduce the English letter by this F, reduce English alphabet by 3, so it becomes C. These are very simple encryption algorithms and decryption. It is a very simple way. Security of programs. Actually, security of programs these programs are in the computer. Better security can be given by avoiding weak points in programs. Weaker points can be created at design time, compile time, and or runtime. Weaker points can be created at the design time is when the software system is designed. Compile time is after designing the software, it should be compiled to understand to the computer. We write programs in a editor and those programs we can identify these codes. To identify these codes by the computer, we should compile them. And weaker points can be created within the compile time also or runtime. After the compile, and we should run the program. When we run the program, there can be weaker points. When designing program functionalities may be written wrong, which gives rise to the program errors. And when designing, actually when we design the program, we should carefully test all the functions of the program to avoid program errors. Program errors. Errors in the programs can occur because of non-malicious and malicious codes. Malicious codes are done by unauthorized persons. Unwanted program codes to the computer. Most of the time, entered to the computer through unauthorized access with the knowledge of authorized persons. Most of the time, these malicious codes added with the knowledge of authorized persons, because for example some cookies, viruses, etc. Virus actually before virus come into the computer, some indications are there, yes or no, like that. We can see the program codes by downloading and when we running, like that. Usually authorized users click yes or like that, then the malicious code will enter. Non-malicious program codes are due to errors in the program codes during development stage of the software. When the developing the software, some malicious some errors can occur. Some program errors in the program can occur. This here is example for the non-malicious errors in a program. In this program, char A1 is an array. The size is 10. That means 0 to 9. We can enter the array 0 to index is 0 to 9. Within the loop, first the I will be the 0, then A1 0, x will be assigned to the array A1 0, then it will print, then begin the loop again, the I will be 1, like that it will go until to the I become 9. Then what happened, I become 10, because here I plus plus, then I will become 10. Then after that y assigned to the a1 I is a1 10. There is no index called I10. If you want to include a1 10, array a1 10, we should change this array to the 11. Then we can assign a10 the y, we can assign y to the array a10. So then it will give an error, but this will not indicate when compiling. This will indicate only when run the program. This is a runtime program. It is called a bound error, out of bound error, because A1 has no A1 array has no index called A10, A1 10. This is called, these are non-malicious. Non-malicious means this program code doesn't access by the unauthorized persons, but these errors occurs by the mistakenly by the authorized persons. Malicious codes is a program code which is unwanted or harmful to the software and data in the computer. Sometimes it may be harmful to the computer hardware also. Suppose some hardware mechanical in earlier computers, the hard disk is a mechanical rotating device. If the software if a software write malicious software code write to the driver of the hard disk to rotate the other side, not the correct side, the other side, probably hard disk will be damaged. Malicious code, there are several types of malicious code called virus, Trojan horse, logic bomb, time bomb, trapdoor, worm and rabbit. Virus is program which can link to a program and spread itself to other non-malicious programs to become malicious program. Virus automatically spread to the other good software, other correct software, and those correct software also become wrong software or malicious programs. Then these software also spread again. Trojan horse is an unauthorized program code which can install to a computer automatically without knowledge of authorized persons, and then this Trojan horse damage, delete or modify the other programs. Trojan horse program codes automatically download or install to the software, the computer, and this Trojan horse software damage or probably delete, and we cannot access this software correctly if the Trojan horse program codes inserted into the computer or download. Mostly now when we download, we should carefully check whether Trojan horse or other malicious codes come. There are another malicious codes are logic bomb. Logic bomb activate when a certain logic condition is achieved. Time bomb is a certain date. When a certain date come, this logic bomb activate, and then after that correct software, the logic bomb will damage to the correct software. Trapdoor is an attribute in a program that commonly uses program privileges such as maintainers persons. A trapdoor is sometimes for the maintainers purposes. Some workers or maintenance workers should have to access these program codes. They can use this data or programs for their purposes. These are called trapdoor. Worm is a standalone program. Standalone program is separate program which creates multiple copies and spread itself through the network, create heavy traffic to the network. Worm will aggregate or add another program. It creates doubling again, and it creates within a few minutes. It will create a huge amount of copies of these worms. So computer will fill by these worms, and the network will also stuck because of these worms, and create when spreading and to the network also. Rabbit works as virus and worm which create multiple copies of to freeze the resources. For example, Rabbit creates multiple copies and saves it in the disk to fill the entire space. The disk hard disk will be filled by this worm, so we cannot use further. The operating system and other software will be stuck because of the memory and the hard disk filled. Controls to avoid threats to the program code. In development stage, in the development stage, controls can be implemented by using concept of modularity, encapsulation and information hiding. Modularity is all the program divided into smaller parts which can handle by each person. So one module can handle by 15 persons or one person, or that clearly visible these what are the errors, all the things when we modularize. Encapsulation is we cannot this module cannot access by another module. This module is separately only the input and outputs are there. We can test black box testing and white box testing using modularity. Information hiding also by using encapsulation. Automatically information hiding will be done. Most weaker points can be identified within the testing process by using the unit test, integrated test, function test, performance test, acceptance test, installation. Using these testings, we can identify the weaker points and we can correct these programs. Introduction to Object-Oriented Programming (OOP). Following topics are covered in this video. Function-oriented programming. Before OOP concept invented, function-oriented programming paradigm was popular. So this video covers first little bit of function-oriented programming concept using C programming, because we have learned C programming earlier. Object-oriented concept. Concept of object and its attributes, methods, parts, and about class. Encapsulation, also called information hiding and inheritance. Abstract class, information hiding, constructor, getter and setter using Java program. Aggregation, graphically and using Java program. Composition and polymorphism. Function-oriented programming. Function-oriented programming and object-oriented programming are two different paradigms of computer programming. In function-oriented programming, fundamental elements are variables and functions. Here, variables of the program are shown within the red color rectangle. Variables are integer data types, numbers called num1 and num2. They are initialized as 0. In this program, there are two functions called calc_avg and calc_sum. Each function has a specific task. Here, task of first function is calculation of average and task of second function is calculation of sum. Calc_avg function is called by typing this command. Object-oriented concept. In object-oriented concept, real-world tangible objects such as people, tree, car, which can touch, and intangible objects such as course, program can be obtained for OOP. In this slide, you can see two objects, person and car. Relationship between these two objects are person drives car. Object is an entity able to save information and able to offer number of operations or behavior. You can see the object person. There are three boxes called attribute, behavior and parts. Similar names for the behavior are operations or methods. Attributes are variables belong to this object. Here attributes are title, name and address. Operations and methods. Operation is a function relevant to the class. Method is the implementation of an operation relevant to the class. An object is an instance of a class. Here Amal, Kamal and Neela are instances or objects. A class is a group of objects with same attributes and methods. Here you can see the class person. Normally class name begins with a capital letter. Parts of class person are legs, arms, head, etc. These are another classes with their own attributes and methods. Encapsulation is also called information hiding. You can see in front of the attributes of class person has minus sign. This sign indicates that the scope of these attributes are private. That is, they can access only within the class. So attributes belong to person, student and staff are hidden to other objects. We can write public methods to access these attributes. Here plus sign indicates public. Inheritance. This slide has three classes: student, staff and person. Other classes in the system needs student and staff, not the person class. But the class person has common attributes and methods to both staff and student. Therefore, the person class becomes abstract class to both the other classes. Abstract class does not interact with other classes. And person class is a superclass to both student and staff classes. Student and staff classes are subclasses. Subclasses are inherits features of superclasses. This hollow arrow head denotes the generalization relationship. Relationship is a relationship. Staff is a person, student is a person. Description of abstract class by Java program. Abstract class in Java program defined as abstract at the beginning of the class. Class name, person and the scope public are defined after that. Scope of all the attributes of the class are private, so they can access only within the class. Constructor. Other classes can create new objects by constructor. Setter and getter. Setter. Other objects can write data to the relevant private attributes in the class. Here, NIC number can write through the method set NIC number. Here, data to NIC number can send by set NIC number method. Data from NIC number can access by get NIC number method. Aggregation. This picture has two objects, department and staff. Staff work for a department. A department have one or more staff. Therefore, a department has a list of their staff. A staff person can left from the department. But both department and staff can exist separately. Therefore, this relationship is a weak relationship. Aggregation relationship is denoted by line with the white background diamond. This is one-to-many relationship. One side is department and many side is staff. White background diamond headed to the one side, that is department. Aggregation using Java. You can see here list of staff class in the department. Its scope is private. In the main class, two staff objects are created called st1 and st2. Then they are added to a list of staff. Therefore, thereafter, new department object called is created. Composition. Composition is a type of aggregation, but with strong relationship. Relationship between university and faculty is a composition. If the university is not exist, faculty would no longer available. So it is a lifetime relationship. Composition relationship denotes line with black filled diamond box. Diamond box headed to one side, that is university. Relationship between faculty and department is also composition. Polymorphism. Both the student and staff have a method called get details. Even the name of method get details in two classes are same, their operations and outputs are different. This is called polymorphism. But in object-oriented programming, I told objects, attributes, behavior, or behavior we call another name method also. Then you can say identify at least four classes. In this picture, can you identify four types of classes? Can you type in chat what are the classes in this picture? Please type. In object-oriented programming, one class is, I will say, one class person. One class is person. Okay. Then can you say what are the other classes here? Yes, student. Student is a subclass from the person. Person is the superclass. One type of class is student, and there are another subclasses called parent, like those things. Then can you type another class? Think of this picture. Then there are other classes, desk. There, can you see another class? Yes. Girls. Girls is yes, periodic table. Yes. Then yes, book. And there are in sub pencil, yes, there are these all the subclass classes. Yes. Pictures. And okay, now you can see there are boards up to the door. Board are one class. You can see AA, BB, CC, DD. Those are objects. The class is board. Board object is one object is AA object. Other thing is now student is class, and if we can suppose this green color wearing team shirt boy, his name is we say Amal. The class class is student, name object is Amal. Okay. Now identify attributes and methods. Uh, what are the attributes of the student? Student attributes. Tell me the attributes of the student. Yes, yes. Name. Student age. Yes, yes. Yes. Student dot age. Yes. Actually, when we write object-oriented programming using C++ like those things, we type like this: student age, student name, dot name. What are the other things? Methods. Type method. Then here in this picture, one method behavior. We can say behavior also. Type of behavior. There are several behaviors. One girl is thinking. One boy is writing. Yes, yes. One voice is what are some other voices? Okay, now yes. The behavior or methods are what are they doing? Actions. Okay, okay. Now are there anything questions from the object-oriented programming? I think you understood some little bit of this object-oriented programming, I suppose. Is it or not? Type any questions? Okay, thank you then. Thank you for participating. Okay, I will stop here.